This is video lecture number 2 for chapter 12, and today we're going to look at attractions between molecules. Remember, a molecule is the smallest group of covalently bonded atoms. These are within nonmetals. Molecules are often attracted to each other by a variety of forces. These intermolecular forces of attraction are weaker than an ionic or a covalent bond, but they're important for determining if a substance will exist as a solid, liquid, or gas. There's only 3 types of forces that we're going to look at, but they're unique, they're different, so it's going to take a little bit of work on your part to understand the 3 different types. The first type of force is called a dispersion force. It's the weakest of all the intermolecular attractions. It's caused by temporary dipoles, positive and negative ends in a molecule, and the strength of the dispersion force increases as the number of electrons in the molecule increases. We can think of it as the mass. As the mass increases, the dispersion force increases. Dispersion is dominant in non-polar molecules. So if you are non-polar, remember symmetry, they are symmetrical, your main force is a dispersion force. So let's look at the diatomic molecules of the halogens. Remember, halogens are group 17. Fluorine and chlorine, the smallest 2 members, are gases at STP. Remember, we can think of it in terms of mass. So the lower the mass, the less force of attraction, and so they tend to be gases. Bromine, we know, is the only liquid nonmetal. And iodine, if we look at the periodic table, is a solid. So as you go down group 17, we start with gases, we change to a liquid, and then the stronger dispersion force makes iodine a solid. If we look at group 18, the noble gases, helium boils at minus 269 degrees Celsius. That's almost absolute zero. Krypton boils at minus 153, and radon boils at minus 62. So, although still cold, it's a much higher temperature than helium. So as we go down the noble gases, the boiling point increases. We have to know that. So here's a diagram that shows a temporary dipole. Means this negative side and this positive side are only temporary, and then there is an attraction for the negative side of another molecule. But the attraction doesn't last, and then they go back to being apart. Second force of attraction is a dipole-dipole attraction. This occurs when polar molecules are attracted to one another. So there's our big difference. In dispersion, it's for nonpolar molecules. In dipole-dipole, it's for a polar molecule. Now we have a permanent negative and positive side to the molecule, which then more strongly attracts a neighboring dipole. So the slight negative region of a polar molecule is attracted to the slight positive region of another polar molecule. So this here represents the dipole-dipole attraction. The third type of intermolecular attraction is a special case of the second dipole-dipole attraction, and it's called a hydrogen bond. It occurs when a hydrogen atom is covalently bonded to a very electronegative atom, specifically nitrogen, oxygen, or fluorine. It forms a very polar covalent bond, remember sharing, because the electron almost loses its electron and acts like it's just a proton by itself, a supercharged magnet. Hydrogen bonds are the strongest of the intermolecular forces, but still much, much weaker than the covalent bond itself. The boiling point of water is H2O is 100 degrees Celsius. Oxygen and sulfur are in the same group, so H2S should be fairly similar, yet it boils at minus 20 degrees Celsius. Why does water boil at a much higher temperature? Because of the hydrogen bond, the hydrogen attached to the oxygen. So we have to recognize that the hydrogen bond is the attraction between two molecules. And that is it for today's lecture, the three types of attraction. So have a great night, and we'll see you tomorrow.